Alright, so there you go. On 1A, that's with your rectangle. It has to start at 63 and end at 90. The height of it is 1 over 27. Part B, 22 over 27 or 0.8148. C, 7 over 27 or 0.2593. Number 2, mean 140, standard deviation 5. Number 3, you draw it, it's centered at the mean, 27.4. Then one standard deviation would be when you add or subtract the 2.9. And I asked you to shade between 290. I think I changed that one on yours. So you have the shading in between. Part B, the interpretations. So I'm probably going to ask you to do this on the test. To interpret, there are two options. It can be written as a proportion or a probability. So it's like saying the proportion of the population between those is 0.6419, or the probability that one value is between them is 0.6419 or 64.19%. So it's as a proportion of the population or a probability for one individual. Number 4A, 0.8907, B, 0.7704, C, 0.9513. Number 5, the Z alpha is area to the right, so that means 0.34 is to the right, so 66 is to the left. Then you have to look in the inside of the table, find the 66, and you get a Z of 0.41. A, 0.1814, B, 0.4383, C, 0.1492, 7A, 0.0091, B, 0.2694, C, 0.0401. 8A is 0.3859. B, describe the sampling distribution. Here's where you need to tell me that it's normal, but it was already given in the problem, so you don't have to state that. The mean is 90, standard deviation 11.06797. C, 0.1841, D, 0.5714. 9A, describing the sampling distribution. So this is where you have to tell me it's normal. Our sample is bigger than 30, so we can assume it's normal here. B is 0.3192, C, 0.0582, D, 0.6549. 10A, describing the sampling distribution. Make sure you know your requirements. When you're talking about p-hat, that's when your n times p times 1 minus p has to be bigger than 10. And your sample has to be less than 5% of the population. So I will be checking that you verified both of those things. Your mean, 0.224, standard deviation, 0.024071. B, 0.9913, C, 0.0336, so that would be unusual. 11, so part A, describing n times p times 1 minus p is bigger than 10, samples less than 5% of the population. Mean 0.63, standard deviation 0.034139, B 0.0139, C 0.2327. 12 is from 0.319 to 0.481, or you could say lower bound 0.319, upper bound 0.481.
What was 10 be again?
0.9913. All right, 13A, your point estimate is just finding that p-hat, so it's 0.75. B, your requirements, n times p times 1 minus p is bigger than 10, sample less than 5% of the population. C, your lower bound is 0.715, upper bound 0.785. Yes, it would be possible that it's below 70%, it's just not likely. 4A, 1,269. B, 1,414. 15A, 1.692. B, negative 2.861. C, 2.177. 16, your p-hat is 0.0625. Your E, 0.0115. Your X is 70. And number 17, your lower bound 6.292, upper bound 20.508. So with the interpretation, we are 99% confident the true value is between those numbers. Like always, guys, I'm not trying to trick you, so this is kind of a pretty good idea of what your test is going to look like. So first thing I asked about was the uniform distribution, so there'll probably be a question on the uniform distribution. Not a lot, because we didn't spend a lot of time on it. It was one part of one section, but you can expect that question on there. So uniform just means everything has equal probability. So it's not a bell shape because the probability is flat. It's the same everywhere. So this one told us between 63 and 90. So on your x-axis, we have to start at 63 and end at 90. Probability is always the same, so it's just a rectangle. The height of this, a couple ways to think about it. The area under this represents the probability. Area is length times width. What is your total probability always? One. Probability always goes to 1. The length of this rectangle, if you start at 63 and end at 90, 90 minus 63 is 27. So to find that height, we would divide by our 27. So the height of this rectangle is 1 over 27. It'll always just be 1 over the length of it. So then part B wants to know the probability exceeds 68. So bigger than 68. So area is just length times width. The width of this is 1 over 27. How far is it from 68 to 90? 22. Just 90 minus 68. So you get 22 over 27, which is 0.8148. Part C. If you're between 70 and 77, so again, the probability is 1 over 27. How far is it from 70 to 77? So you get 7 out of 27, or 0.2593. So in the test, I'll probably ask you to draw me that graph and ask you maybe one of the probabilities.
For B, how do you know to count 68 or not?
Well, it's just the distance between them, so I just subtract them. Other questions? Number 3. All right, so on this, I was asking you to draw some things. We have the normal curve with our parameters labeled. That means when you have a normal curve, that's really not too symmetric, but let's pretend it is. What's the center? The mean, which was? Okay. Then when it starts to flip out like this, that's your one standard deviation, right? So to find, it said a standard deviation was 2.9. So to get the first 27.4 plus 2.9 would be what?
3.3.
And 27.4 minus 2.9? Right, so that's drawing it with your parameters labeled. So I might ask you to do that on the test. And then I asked you to shade between 29.3. So 29.3 would be about right here. And 23.7, which would be a little bit below this. And so then you're just shading that. So that probability is just the area between those two numbers. part B, the interpretations. So you can expect me to ask you that on the test. Two ways to interpret it. This was the miles per gallon for our motorcycle. So you can interpret it as a proportion. So the proportion of miles per gallon between, and this was the 29.3 and the 23.7. Is, and what did I tell you, 0.6419. So you can interpret it as a proportion of everybody. I took all my motorcycles, this much was between them. Or I could look at that as a probability. If I select one motorcycle, the probability that the miles per gallon will be in this window is this much. So the and when you're talking about probability, you can give it as a decimal, or you could say 64.19% if you want to write it as percent, either one. So when I ask for the two interpretations, it's either a proportion of the entire population or the probability of one individual. Is that one okay? So make sure you know how to do that on your test. Okay, next question we asked about was number 5. So the Z alpha, you will have to do a Z alpha probably on your test. Alpha is just area to the right. So 34% is to the right. So you are just roughly guessing where that might be. And then we have to find the Z that corresponds to this. Just for the sake of our picture, if I said it was like Z of 0.7, where would your line be? Yeah, if you want 70%, then you would have to make sure your line was down here, right? Make sure it's reasonable. If it's less than 50%, then it would be on the right. If it's bigger than 50, it would have to go all the way over to the left. Okay, so if 34% is here, 1 minus 0.34, 0.66. So everybody grab your table. We are looking for when the probability is 0.66. So inside the table, you're looking for 0.66, or as close as we can get. So it looks like the closest is 0.6591. And then you give me the Z value, which is 0.41. Everybody okay with that? Yes, ma'am.
Okay, so whenever I see this Z, I think of the area to the left because that's the answer. But if it has a small number next to it, that means it's to the right.
Yes, that's just a notation thing. It does the opposite of what your table is. So when it's that subscript, that's talking area to the right every time. Other questions there? Next. 6B. Does anybody need me to work out all of 6? Are we okay with A and C? So B is asking for the probability that a score, so one particular value, so that's like your X, is between 20 and 26. All of these problems, guys, we are converting these to Z's. The only thing that's different is how you do that depending on your variable. If it's an X bar or a P hat, the standard deviation we have to find, but otherwise if it's just the regular variable, we can get those from the problem. So I need the Z for each of these. Z is your value minus the mean, which it told us in the problem. The average score was 20.8, so that's your mean, divided by your standard deviation, which was 4.6. All right, so if we calculate this first one, we get a Z of negative 0.17. The second one, you do your score minus the mean divided by standard deviation. And we get 1.13. So now you're finding the probability that your Z is between negative 0.17 and 1.13. So what you do is look both of those probabilities up and subtract them. You have to do the bigger one first, so that would be the 1.13. So that gives us 0.8708 minus negative 0.17, and that gives us 0.4325. And so then you subtract and you get 0.4383. So anytime it's between two values, you need to get the Z for both, then get the two probabilities and subtract. Questions on that one? So next one, we had question number 8. So this one tells us the charge life of a certain battery is normally distributed. So I've already told you it's normal. That means we don't have to check if it meets any certain requirements. It's assumed to be normal. I've given you that. The mean is 90 and standard deviation is 35 minutes. So part A, I want the probability that a battery lasts more than 100 minutes. Am I talking, did I make any mention of the mean life or the proportion in this? No, we are not talking about an X bar or a P hat here. I just want the probability that one battery, so X, is greater than 100. So convert it to a Z. Your X minus mu over sigma, and that gives you 0.29. So now you need to find the probability that Z is bigger than 0.29. How do we do the greater than probabilities? All right. So then if you look up the probability for 0.29, for the sake of time, I'm probably just going to start telling you what these are. 0.6141. Does everybody know how to look these up on the table? Okay. And so then if you subtract those, you get 0.3859. So part A was just like questions 6 and 7. You were just finding the probability of a particular value. Part B says describe the sampling distribution of X bar. So anytime I ask you to describe a sampling distribution, you have to tell me if it's normal. We get to skip that here because I already told you in the problem it was normal, so we don't have to prove it is. Then you need the mean and standard deviation for that variable. Anytime you forget these, you can always go back to your formula sheet. If you're looking, your X bars, that was under chapter 8, it's the very first bullet here. Your mean for X bar is just your regular mean. But the standard deviation for x bar is your standard deviation divided by the square root of n. What is my n here? 10. And we do that, remember, we try to keep a few more decimal places on these standard deviations just to make our calculations later on more accurate. Then part C, I want the probability that a random sample of 10 batteries has a mean charge life of more than 100 minutes. Do you guys see the difference between part A and part C? Part A was one battery, more than 100 minutes. Part C, I want the mean for my group of 10 batteries. So we are talking about x bar here being more than 100. Everybody with me there? So change it to a z. Same thing as always, but if your variable is x bar, you have to use the mean and standard deviation for x bar.
So it's x bar because of what?
Because it's the mean of that group of 10. So it's the probability that a random sample of 10 batteries has a mean charge. Keep in mind, if you rounded differently than I did on these, you might get a slightly different answer. So that's why its work is so important here. So we are finding the probability that your z is greater than 0.9. So greater than, we do 1 minus 0.8159, and we get 0.18. Part D, what's the probability that a sample has a mean? So again, we are talking about the sample mean less than 92. So change it to a z, your value minus the mean divided by the standard deviation. So we get 0.18. So we're finding the probability that z is less than 0.18. If you want less than, that's just reading it from the table. So 0.571. And make sure you correct anything that you missed here. Are there any questions on number 8? Problem number 9. We have a random sample of size n equals 36. You know, guys, if you're seeing that I'm talking about a sample in these, that's a good indicator I'm either going to start asking you about p hat or x bar. You notice on questions like 6 and 7, I didn't tell you my sample is this big. We were just talking about a particular value out of the population. So when I give you an n, that means we're going to be talking about a different variable here. All right, part A describes sampling distribution of x bar. So I did not tell you it was normal. When you're dealing with x bar, what's the requirement?
Greater than 30.
Right. If it's not normal, n has to be bigger than 30, and it is, so it's normal. So that's the first point you would get there. Then I want the mean and the standard deviation for x bar. So the mean is just the same as the mean of the population, which was 64. Standard deviation is population standard deviation divided by the square root of n, and you get 3. Part B, the probability that x bar is less than 62.6. So always change it to a z. 62.6 minus your mean divided by standard deviation. You have to use the mean and standard deviation for x bar because that's our variable. And that gives us a negative 0.47. So we find the probability that z is less than negative 0.47. Less than is just from the table, so you get 0.3192. Part C, the probability that x bar is greater than or equal to 68.7. So greater than or equal to, we have to do 1 minus, but first you need your z. So your value minus the mean divided by the standard deviation for x bar, which gives you 1.57. So you need probability that z is bigger than 1.57. So that's 1 minus 0.9418. So we get 0.0582. Guys okay there? Part D is between. We've done one between example already. When I ask for area between, what do you have to do? Change them to z's and then subtract those probabilities. So your first z, 59.8, minus your mean for x bar, divided by the standard deviation for x bar, we get a negative 1.4. Second z, 65.9, minus the mean for x bar, divided by standard deviation for x bar, we get 0.63. So then, if you look up, the 0.63 would be bigger, so you look that one up first, that's 0.7357. Minus, if you look up negative 1.4, that's 0.0808. You get 0.6549. So every time, these are very repetitive, you change it to a z. So all you really have to do is find your mean and standard deviation, so you know how to convert it to a z, and then you're reading from the table. When you read from the table, if it's less than, it's just the number, greater than, 1 minus, between, you subtract them. Is that okay with everybody? Alright, question number 10. This time I'm asking about p hat. I said approximately 22.4% of adults are smokers. We have a random sample of 300. So part A, describe the sampling distribution. This is the part that you may need to look back and review before tomorrow. What are the criteria for p hat?
And like your
That formula has to be
times 1 minus b has to be greater than 2.
Perfect.
We should get this down. Need A's in this one. Trying to like gauge. Yes, you will.
Okay, so my N is 300. My P would be what?
1.224.
1 minus 0.224. That equals 52.1. That's bigger than 10, so we're good there. Would 300 be less than 5% of all adults?
Yes.
So we met our criteria. When I ask you to describe the sampling distribution, I also want the mean and standard deviation. So again, if you forget those, go to your formula sheet. It's the second column on chapter 8. The mean for p hat is just your p, so 0.224. Standard deviation for p hat is the square root of p times 1 minus p divided by n, which was 300 here. And we get a standard deviation of 0.024071. Again, the number of decimal places you keep can slightly change your answers, so just make sure you're writing it down so I know what you're using. All right, part B. In my random sample of 300, what's the probability that at least 50 are smokers? Okay, here's the issue though. I'm talking about p hat, so I need a probability for p hat. 50 is not my p hat. P hat is a proportion, so how do we find it? Again, that formula is on your formula sheet. And so that is 0.16 repeating. Keep a few decimal places just to prevent rounding error. We wanted at least, so greater than or equal to 0.1667. So just like always, change it to a z. Your value minus your mean divided by your standard deviation. This is also a place where you would be able to see if you have a mistake. Like if you had used 50 right there, what would happen when you converted to a z? You would have a huge number that isn't on your table, so you know you've done something wrong. Okay, so my z here turns out to be a negative 2.38. So we need the probability that z is greater than negative 2.38. Greater than means 1 minus. And if you look up 2.38, that's 0.0087. So we get 0.9913. Are we okay there? Part C. Would it be unusual if 18% or less, so we're finding the probability that your p hat 18% or less, so less than or equal to 0.18. So get your z, 0.18 minus the mean for p hat, divided by standard deviation for p hat, and we get negative 1.83. Find the probability that z is less than or equal to negative 1.83. Less than just means you read it from the table. So we get 0.0336. And I asked if that was unusual. Yes, why?
It's less than 5%.
Less than 5% is considered unusual. Right, so what you guys have to remember, p hats and x bars, you need to know your criteria, and you need to know how to change them into z's. So getting your mean and standard deviation. Is that okay? The next one we asked about was number 14. It tells us a school administrator wants to estimate the percentage of full-time college students who have credit card debt of $2,000 or more. What sample size should be obtained if she wishes to estimate the estimate to be within 2.5 percentage points with 94% confidence? Okay, I want everybody looking at the formula sheet here. We're talking about sample size. So if you look under chapter 9, it's got one column says confidence interval and one column says sample size. So we're talking about sample size. Are we dealing with p hats or x bars here?
Yeah.
P hats. If you look in part A, it says the percentage is 34%. So when you see that 34%, we're talking about p hat. Okay. So with p hat, we have two options. We have the first one if we are given a beginning level of confidence, and the second one if we are not. Do we have, or sorry, a beginning estimate. Do we have an estimate here? Yeah, that's what the 34% is. So this is the formula we will be using. Here, p hat, 1 minus p hat, z alpha over 2 divided by e squared. So we need all of our variables. The p hat is the 0.34. That tells me in the problem. The error, how close do we want to be?
2.4 percentage points.
2.5 percentage points, so that's 0.025. Okay, the z alpha over 2, this is the one that you need to think about. We said 94% confidence. If you look at your normal table, some of these are given at the bottom. Is 94 one of those? No. I might have done that intentionally. You might expect on the test me to ask maybe one of them where you actually have to figure it out from the table instead of me just giving it to you in the bottom. So what that tells me is I want 94% to be in the middle. So how much is left for each side? 6 to split up over the two sides. So each side is 0.03. When you look it up from the table, z gives you everything below. So what probability do I need to look up? So I go to my table, I'm looking on the inside and finding 0.97. So the closest we can get is 0.9699, and that is at 1.88. So that's my z. Does everybody understand how I got that zeta? So now I have everything I need to plug into the formula. So 0.34, 1 minus 0.34, 1.88 divided by 0.025 squared. Put that all in your calculator and you get 1,268.99. If you read on your formula sheet under that sample size stuff, it tells you that regardless of what you get, you always round up. Even if I got 1,268.001, that tells me 1,268 people is not enough, so you would always round up. So we need a sample of 1,269. Always, always, regardless of the decimal, round up. Part B says no prior estimate is used. So I can't use that 0.34. So if I'm going back to my formula sheet, that tells me I'm using the formula where it says there is no prior estimate. So that's my n equals 0.25 times the z alpha over 2 divided by e squared. So my z alpha over 2 is 1.88. My error is still 0.025. Plug all of that into your calculator and you get 1,413.76. So always round up. So you need 1,414 in your sample. This second one will always give you a bigger number. This is the biggest possible sample you would need.
I see why you used the formula in E, but why did you use it in A? What was it like Q, what it said?
Well, we had a prior estimate because it told us to use the percentage of 0.34. So that's when you use the formula that has the E. Other questions? Right. Problem 17. Okay, a survey asking 40 Americans how many books they read per year found that X bar is 13.4, S is 16.6. Construct and interpret a 99% confidence interval. All right, on these confidence intervals, which one do you use when? If your variable is p hat, what confidence interval are we using? That we use the z's. If you're doing that on your calculator, remember you can go to stat, tests. You guys might want to look at this and make sure you remember. So if your variable is p hat, you are going to go to A, which is the 1 proportion z interval. Okay. If our variable is x bar, then what interval do we need? 8. Right. That's when it's number 8. It is the t interval. Again, if you forget this stuff, you don't have to memorize all that much. It's all on your formula sheet. You just have to know how to use it. If you're looking under confidence intervals, the first bullet says if you have an interval about p, and then it tells you how to calculate it. And we see z's in there, so that's our z interval. Second one, if you have an interval about mu, about the mean, then it gives us that formula. So if I don't specify on the test to do it by hand or on the calculator, you could do either one. I'll show you both to make sure we all remember. So if we wanted to do it by hand, we have to use this formula. So your lower estimate would be your x bar. What was our mean here?
13.4.
Minus t alpha over 2. This is the thing you have to remember. Let's look at our t table. The only time we use this t is when we're finding a confidence interval for x bar. All right. We want a 99% confidence interval. So 99% is in the middle. That means we have 1% to divide over the two sides. So each side is 0.005. So we are looking at T of 0.005. So that's the number across the top. Then down the side we have degrees of freedom. How do you find your degrees of freedom? My n here is 40, so n minus 1 would be 39. So you're going to go down to row 39 over to 0.005, and you get 2.708. S was given to us, 16.6. N is given to us, that's our 40. So if we plug this in, we get 6.292. To find the upper, the only thing that changes is you go back and switch it to a plus in the middle, and that gives you 20.508. If you wanted to do it from your calculator, we are talking about the t interval, so that is number 8. And if you go into stats tests, we are basing this off stats. Everybody do it with me so we make sure we know where it is. So you need to go to stat, over to test, and then it's number 8. On there it has data or stats. Data is what you do if you entered everything into L1. We want it on stats, so then it just asks us the questions. X bar, well, that was 13.4. My standard deviation, that was 16.6. My n was 40. My confidence level was 0.99. And so you can calculate and check your answers that way. Mine are slightly different due to rounding, but they're pretty close. Again, if I didn't specify, you could do either one. Then it asks you to interpret. So that's writing the sentence. So we are 99% confident we are talking about X bar, so that is the mean, so the population mean. Is between 6.292 and 20.508. Does that mean it has to be? No. Would it be likely that it's not? No. 99% chance it's between those two numbers. So it doesn't have to be, but there's only a 1% chance that it's not. Okay, we have 2 minutes. Yes.
Okay, can you go over 15B?
Sure. All right, so this is finding the t-value. So we need this table at the back. It tells us the area to the left is 0.005, and we have 19 degrees of freedom. Now, your table gives you area to the right, but what we know is, just like the normal curve, the t-curve, it's symmetric on both sides. Okay, it's centered at 0. So if we could find the t-value up here, then on this side it would just be a negative of that. So we go to 19 degrees of freedom, 0.005, and we get 2.861. That would be